Hello, welcome to everyone. In this video, this is our lecture number 1 for the solve of quantum mechanics problem for mainly semester 3 of graduation in physics, BSc physics. You all know that there are different playlists for different portion of physics for mainly graduation and others examination for like IIT JAM, JEST, SET, CSR, NET, TIFR. You all know in this channel these are regarding different physics related video are available in this channel. So if you are interested, you can go through the description box. You will be get different physics related link, playlist link. You can avail this video also. Okay, this is the journey for the quantum mechanical lecture 1, and this is the problem solution series, and there are separate playlist for the theoretical part also, right? So if you want to watch this one also, you will be get the link in description box, right? So let's start. Actually, in this lecture we want to discuss the question asked in this book, that is the Dr. S.N. Ghoshal book's Quantum Mechanics for chapter 1, that is the foundation of quantum theory, which consists mainly uh, the Compton effect, photoelectric effect, Planck's radiation, this type of, that is the basic concept of the quantum theory which deal with this chapter. So look at this question asked in this book problem actually, because problem number 1 to problem number 7 which asked will be discussed in this lecture. So let's start with question number 1, which says that the find the stopping potential for photoelectric emitted from the photocathode of rubidium having the work function. This is the work function, that is 2.1 eV when it's irradiated successfully with the light of the wavelength this. There is three wavelength, and you need to find out the stopping potential in these three cases, right? So you all know about this photoelectric effect, that is the when light is irradiated on this metal and that emits the electron which are towards to this direction. But when if we apply this potential at the negative at this terminal, then this react or they repel this electron, this negative plate repel this three electron. That's why that electron is stopped. So how is the value of this potential such that the electron is stopped? That is the stopping potential, right? So there the incident energy used in two ways. First one is the work function, that is the energy required to the electron from the surface, from the internal to the out of this surface, right? So this is the minimum energy required which is comes from this metal side to the outer side is the called out work function. Okay, so this work function is used, and the rest of this energy from this h nu used as the kinetic energy of this particle, and this kinetic energy of this particle is stopped by the stopping potential. So this kinetic energy of the particle is equal to the potential energy applied from this source. So the equation will be like that: h nu minus work function. This is the applied energy or incident energy. This is the work function which used for the electron coming from outside this surface, which is equal to the kinetic energy, which is nothing but the potential energy supplied from this source. So just rearranging this equation, you will be get that expression and put this value. H is the Planck constant, c is the light speed of the light in free space, so h is equal to like that, and this is the electron and lambda is Armstrong. So you will be get this expression. So just find out this relation in the lambda in Armstrong. So put this value for lambda is 3650 Armstrong. You will be get the in this expression you will be get this value, that is 1.3016 ev. Okay, for lambda 2 in this expression you will be get 0.7608, and for lambda 3 this will be 0.45, like that. So you can see here that with increasing this lambda, that is the decreasing the energy, the stopping potential also decreases. So with increasing lambda, the potential will be decreases. With increasing lambda means decreasing potential, decreasing energy. That's why the stopping potential also decreasing. I think clear about all this thing. If there is any doubt, you must comment in the comment box. Go to the next question. Next question says, a photocathode is irradiated successfully with light of wavelength this that. So these are the defined wavelength which are irradiated successfully with this light. If stopping potential for the photoelectric defined cases are like that, so these are the stopping potential for that defined wavelength. Like here, for defined wavelength we will be get different stopping potential. These data are given here, and determine the threshold wavelength for emitting surface and Planck constant from the graph V0 against lambda, and calculate the work function for the emitting surface. So just think about this equation, that is the total energy H nu is used as a two portion, that is the work function, minimum energy required to coming out from the surface to the surface, plus kinetic energy. So nu is nothing but c by lambda, and nu 0 is nothing but c by lambda 0, and kinetic energy will be equal to the potential energy, that is the uh, qv, that is E into v0. Okay, E into v0. So h c by lambda minus like that. So if we arrange them, you will be get this type of equation. So this is nothing but the intersect equation of this format, that is stopping potential v naught versus 1 by lambda curve will be like that. So if you get this is the value of lambda, from here you will be get the value 1 by lambda, and this is the stopping potential. Using these two data you will be get the graph like that, and this extended data will be intersect like that. So this intersect is nothing but 1 by lambda 0, and this lambda 0 is threshold wavelength, that is the maximum wavelength, that required to forming this photoelectric effect, or in the other sense this is the minimum wave frequency. If you convert it into frequency term, we can say this is the minimum frequency which is required, frequency which is required to happening this photoelectric effect, otherwise this electron cannot ejected from this metal. Okay, so this is the minimum energy, or in terms of the larger wavelength, this wavelength is threshold wavelength. And from this slope, in the slope is nothing but E by AC. So you will be get this value of H Planck constant, and you will be get this work function. This is the work function, this is the minimum energy required to coming out this electron from the surface. So this is the, so you need to plot this theta in a graph, and extended this graph, you will be get these two intersection. From this intersection you will be get threshold wavelength, from this intersection you will be get work function, and from this slope you will be get this value of H. This is the conclusion. Okay, next question. Next question says, prove that the energy of recoil electron and Compton scattering can be expressed as a function of direction of the emission of the electron by the following formula. So this is the formula you need to prove that, where alpha is h nu by me c square. Me is the mass of electron. So in theoretical part we will be discussed, that is the kinetic energy of recoil electron is nothing but the H nu is the incident energy, and this is the recoil energy, recoil photon energy, or the ejected photon energy. So there are separation of difference is the recoil energy, kinetic energy of recoil electron. So using this value we will be get this expression. This will be proved in theoretical class, right? And you can see that this is the slide we need to explain to get this expression, to get this kinetic energy expression. We need to discuss about this calculation. That's why I just you can just taking these two things, nothing but one is energy conservation, and second one is the linear momentum conservation. From energy conservation, and these two are the linear momentum conservation, and you need to remember the relativistic calculation. This is done by relativistic calculation. In this calculation you can easily find out this Compton shift, and after that you will be get this value of kinetic energy. Okay, so don't worry, we will be discussed in the theoretical class in detail, but at this moment you can just remember this kinetic energy expression of recoil electron is like that. Okay, And there are also this relation between theta and phi. What is the theta? You can see here in this diagram, this is the value theta, this is the incident photon, this is electron, static electron, whose recoil at that angle is theta, and this emitted photon, that is the ejected photon, that's angle made is phi. Okay, these two are angle is theta and phi, and their relation is cot theta equal to 1 plus alpha tan phi by 2. From here you will be get tan phi by 2 equal to, like that, put this value, you can this kinetic energy is like that. So if you divide it by cos square theta, you will be get, this is tan square theta, this is tan square theta, 1 minus cos square theta equal to sec square theta. You know sec square theta is 1 plus tan square theta. If you put 1 plus tan square theta and common out, you will be get this expression, and put this value, tan phi by 2 is cot theta by 1 plus alpha square. So this becomes in terms of theta. After getting these things, you will be multiply by this sin theta, you will be get this expression, and change sin theta into cos theta, you will be get this expression. This is very simple, but you need to know about these two expression. You need to know about these two expression, that is the kinetic energy expression and the relation between theta and phi. You need to these two relation. You can see this calculation done here, but I don't want to explain all these things at this moment. Okay, go to the next question. Prove that if during Compton scattering the recoil electron energy is very low, non-relativistic. If you take this in the previous, I say that this was taken as the relativistic case. In the relativistic case, we will be get this expression. But if you this take is the non-relativistic case, you need to change, that is you need to showing or prove that, that is the change in wavelength, that is the called Compton shift. You can also say this is the Compton shift, and this can be written as like that. Okay, so there is two things. One thing is the conservation of energy, and another one is the conservation of the linear momentum along the x-axis as well as in the y-axis. So from the conservation of energy, you can see that is the h nu, that is the incident energy of the photon, equal to the ejected energy of the photon plus kinetic energy of electron, and this kinetic energy of electron can be written as p square by 2a in case of non-relativistic case. But in case of relativistic case, these are the different. You can see here, this will be like that, this energy will be like that, that is mc square minus m0 c square. But here this is p square by 2m, and the linear momentum of conservation can be written as this hc by h nu by c, this is h nu prime by c cos phi along the x direction, and this is p cos theta. Similarly along y direction, this will be like that. So after getting these three equation, you just from equation 2 you will be get this equation, and from equation 1 you will be get this one. So adding square and adding this with sines and cos, you will be get p square, this will be the value, and p square will be like that from equation 1, that is the equation for the energy. So this become will be like that, and nu minus nu prime will be like that. So just rearranging them, you will be get delta lambda, that is the lambda prime minus lambda can be expressed as like that. So this calculation, I think you can do that. If there is any doubt, you must comment in the comment box. Next question. Next question says, assuming the photon energy h nu, which is 2 mec square, calculate the angle at which the recoil electron emitted when the Compton scattered at this. So you need to find out the value of theta when phi is like that. In just before we know about this relation, that is the relation between theta and phi. What is theta? Theta is the angle of electron where the recoil electron is ejected, and phi is the angle of this irradiated photon, and alpha is nothing but h nu by mc square, and you can see here h nu equal to 2mc square. So your value of alpha equals to 2. If you put this value of alpha 2, this becomes tan theta is 1/3 cot phi by 2. So putting this value of phi, you will be get the value of theta. If you put this value of phi, you will be get value of theta. So this phi, this is tan theta, and angle of theta equal to just inverse. So you can see that is the phi 0, theta pi by 2, phi pi by 3, pi by 6, pi by 2, pi by 4, 2 pi by 3, pi by 8, and pi, this is 0. Okay, now The next portion of this question says, draw a polar graph of the energy of Compton scattered photon against the angle of scattering. Draw a similar polar graph of energy of the recoil electron against the angle of emission of electron. Okay, so you need to draw two polar graph. First one is says that is the energy of Compton scattered photon against the angle of scattering. So you need to draw the polar graph between the Compton scattered photon, energy of the Compton scattered photon and the angle of scattering. Okay, so this relation is says h nu prime, that is the energy of the scattered photon, and this is the incident photon, and this will be this. And you know the value of alpha. Value of alpha is 2 here. Here the value of alpha is 2, right? So value of alpha is 2 here. If you put this value, it's become like that. Now think about the value of phi, value of energy at different phi. When phi is 0, when phi is 0, cos 0 is 1, so this becomes 0, so this will be E, no problem. When phi is pi by 3, when phi is pi by 3, cos pi by 3 is half, so 1 minus half is alpha by 2, and alpha is 2, that is 1, so this is E by 2. When pi by 2, cos pi by 2 is 0, so this will be 1 plus alpha, and alpha is nothing but 2, so this is E by 3. And then if you put this value, that is the phi is 2 pi by 3, so this is 2, if you take this is 2 pi by 3, you will be get the value, that is 2 pi by 3 is minus up, so this becomes minus up, that is 4, and this is 2 into 2 4, so you will be get this value like that. If there is any doubt to getting this value, you must comment in the comment box. After that, you can plot this polar diagram like that. Think here, when phi is 0, actually in polar graph you can see, if you take this thing in polar graph, you will be get this point in the two things, that is the r and this is the theta, r theta. You need to change the angle and the theta. So at angle 0, this value is E, so this point you will be get this point. Okay, you will be get this point. Now angle pi by 3, that is like that, and this is E by 2, so this total is E, so this is E by 2. When pi by 2, this is E by 3, this is E by 3. When 2 pi by 3, this is E by 4. When pi, this is E by 5, this is E by 5, like here. Okay, this is 4 pi by 3, this again increased pi by 4, 3 pi by 3 pi by 2, this is E by 3, and this is 5 pi by 3, this is like that. So this is like laugh sign, but this is not terminated at 0, this is like here E by 5, this point is, this distance is E by 5, this is E and this is E by 5. I think you clear. This diagram will be like that. I just redraw this diagram, will be like that, uh, like that. This will be symmetry, this will be symmetrical, this will be symmetrical. Okay, this will be the polar diagram of this. And the next portion of this question says that polar graph, in the similar polar graph of the energy, draw a similar polar graph of the energy of recoil electron against the angle of emission of electron. So this will be draw in this relation, which is proved in this previous question, that is the kinetic energy of recoil electron related with this angle theta. You know the angle theta is, this angle is theta, and the kinetic energy of the recoil electron related like that. So after in this value of theta is 0, cos 0 is 1, if you put this will be like that. I think you can check this table. After putting this value of theta, you will be get the value of cos theta, and you will be get the kinetic energy of recoil electron. Now plot this diagram. At theta is 0, when theta is 0, this value is 4 pi by 5. When pi by 3, this is E by 8, this is pi by 2, this becomes 0, and this increase, and this 3 pi by 2 also 0, like that. So this will be dumbbell shape. I think this is dumbbell shape, right? Dumbbell shape, you know, this is the p cell of the any atom. SPDF. S is spherical, P is this dumbbell shape, SP there is parallel dumbbell shape, overlap like that. So this will be the like dumbbell shape of this question. So I think clear. I think this is clear all of you. If there is any doubt to understand this solution, you must comment in the comment box. Go to the next one. Next question says, what is the maximum kinetic energy that recoil electron can receive during the Compton scattering of a photon of energy h nu? That is, the energy of the photon is h nu. You need to know about the maximum kinetic energy of the recoil electron, which can be obtained. So this expression we already discussed in this class. This expression, that is the kinetic energy of recoil electron related with this angle, that is the angle of recoil electron. You remember this diagram. This angle is recoil electron. Okay, so this relation is done here, and alpha is h nu by mc square. Okay, so this will be maximum if their first derivative is 0. So if you take the first derivative of this expression, you will be get this value h nu to alpha into like that. Just taking this derivative, h nu to alpha is constant. Derivative of this is to cos theta, and cos theta is derivative minus sin theta, and lower side is, and derivative of this portion is this square. This cos square theta is here. If you derivative this lower portion, you will be get alpha square to cos theta sin theta. Okay. Okay. So taking this common out, you will be get finally like that. So sine to theta is 0, so theta is 0. So maximum kinetic energy will be like that. So the kinetic energy of recoil electron will be maximum when theta is 0. Remember this diagram. This theta 0 means the electron will be ejected from that, and from this relation, when this theta is 0, all of phi is 180. You can say theta is 0 or phi as 180. The energy of the scattered photon will be maximum. 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 Clear? Okay. Go to the next one. Next question says, calculate the energy of gamma ray which suffer Compton scattering from electron at rest such that angle of scattering of photon and the angle of emission of recoil electron both is 45 degree. So this is the incident gamma ray, this is the scattered photon, and this is the recoil electron. This both angle is 40 degree. You know this relation previously, that is tan theta equal to cot phi by 2 1 plus alpha, and where alpha is h nu by mc square. So tan 40 degree cot 40 by 2. So from here you will be get the value of alpha. After getting value of alpha, you know h nu equal to alpha into mc square. So put this value m and c square. M and c will be get 0.513 mega electron volt. So h nu is nothing but 1.16 mega electron volt, and alpha is 2.27. We already obtained here. Alpha is 2.27. So the energy of this scattered photon will be like that. Put this value, will be get this is the energy of the scattered photon. Calculate energy of the scattered photon is here, and the energy of the gamma ray, that is the incident gamma ray, which is like that. Okay, this is the energy of the incident gamma ray. This is the energy of incident gamma ray. Okay, and this is the energy of scattered photon. Scattered photon. This is the energy of scattered photon, and this is the energy of incident gamma ray. So I think clear. Today that's it for today. This is all about me, and this is my contact detail. You can connect me with this Telegram channel, and this is my online platform, and this is my YouTube channel details. Go to this channel, we get different physics related video, some mathematics part. Like this session. If you learn something from this session, share this video with your friends. Either he or she also get benefit from this video. Subscribe this channel if you're new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming video. So take care. We'll meet in the next video as soon as possible. Thank you.